Good afternoon, this is Schweitzer, and this is just a quick little video on how my reductions potential chart works. This is a reaction sheet that we would use during this chapter on reactions. It's going to be used for an oxidation reduction reaction. Now, one thing before we get started here, an oxidation reduction reaction is a reaction that has basically an exchange of an electron. One item loses an electron, one item gains an electron. If you're losing, lose electron oxidize, gain electron reduce. Okay, so this would be like if this is A and this is B, then this would be the reaction for this would be A goes to A plus, and then here's the electron that I lost. We call this oxidation, electrons on that side. And of course this guy would be B plus the electron that it got from A yields B plus. A little bit of a simplified version. That's basically it. So every time someone gains or loses electrons, how well A wants to lose this electron is sometimes described what we call a voltage. And how much B wants to pick up an electron also is called a voltage. Alright, so in this situation, a positive voltage means it's thermodynamically favorable for it to do this. So a positive means it's thermodynamically favorable. I use a human little thing there just to show that, but really it means that this thing is going to spontaneously want to go from reactants to products. So it wants to happen via energy. If it's a negative electrical potential, that means that the process to go from reactants to products doesn't really want to go by itself. It's like rolling a ball up a hill. You would need to invest energy to do that, but it would go backwards all by itself. But this is whatever's listed isn't going to happen on its own. It needs to be driven. All right, so in this case, how does this chart work? You'll notice in the chart that it only shows a list of things gaining. Okay, electrons are on the reactant side. So that being said, it's only showing things gaining. Well, I thought, like I said, there's both a gainer and a loser. That's fine. So we do here for this, we could take an example. Let's say like pretty common example might be, let's say copper metal plus zinc 2 plus. All right, now they're going to exchange and produce copper 2 plus plus zinc metal. Okay, so then that means the copper goes from no charge to copper plus 2, and then there's 2 electrons that it's going to give away. So the copper is going to give electrons to the zinc, and the zinc is going to take those 2 electrons, and they are going to produce zinc metal. This is reduction. It's gaining electrons reduced. This is losing electrons oxidized. Leo Alliance is GER. Okay, so each of these guys has a voltage. Perfect. Remember, the chart only shows things that are gaining. So let's go here and find zinc. And zinc will be on this chart exactly as we see it. That's really important. So zinc, there it is, way at the bottom. Zinc gaining electrons forms that is a negative 0.76 volts. So let's go ahead and put this on here. Jump ahead 2 pages. Negative 0.76 volts. Okay. What about the copper? So the zinc is not too fancy about taking on these 2 electrons. It's negative. All right, let's go to the copper. Now the copper, remember, is this guy is not gaining. So how do we deal with that? Well, you find the reaction on the chart, and you'll notice that right here, copper plus 2 electrons, use copper metal, it's actually backwards of what we used. That's not the reaction. We're looking for copper metal goes to copper plus 2 electrons. That's backwards of what we have here. So we take this guy, we flip it to a negative 0.34. That's the key idea that you want to use. So in every exchange, there's going to be both um, an oxidation and a reduction. From that chart, every single time, the oxidation is going to have to get flipped every time. So it's in this case, it was, oops, got that out there. Again, what was it again? it was a positive 0.34, so I have to flip it to a negative 0.34. All right, and this is a negative 0.34 volts. All right, add it up, I got a negative 1.1 volts, and in this case, that means that not only does the copper not want to get rid of the electron, zinc doesn't want to take it, and this would have a no reaction. Why is no reaction? It's not thermodynamically favorable because I have a negative overall voltage. But that's in general how you work the chart. Thank you.